Welcome to AP Chemistry, where we will practice balancing acid-base redox reactions. We're going to go down to the fifth problem here on this worksheet, where we are going to balance these redox reactions in basic solutions. So the first step is actually all of the first few steps here are the same as when it's an acidic solution. It's just at the very end we have to do something different. So we're going to first determine our oxidation states here. H2O2 is hydrogen peroxide, and that is our one exception for oxygen, whereas oxygen is normally -2 oxidation state. In this case, each one is -1, so that the total of O2 in a peroxide is -2. That gives us a total of +2 from the hydrogens, which hydrogen is then each individually a +1. Then over here, oxygen is its normal -2, so making a total of -4 from oxygen, +4 for chlorine. On the product side, we have -2 again and a total of -4 from oxygen, but the total from this molecule needs to equal or add up to -1. Therefore, this chlorine is a +3. And elemental oxygen is 0. All right, so that means the oxygen, this one is slightly tricky, so we're going to do chlorine first. Chlorine went from a +4 to +3. And that means it went down on the number line and the chlorine is reduced. That leaves us with oxygen better be oxidized because there's no other hydrogen or any other element in the problem. So the oxygen better be the one that's oxidized. So we're going to take the -1 oxygen from the peroxide and go to the 0, the elemental form. And that gives us oxygen is being oxidized. Of course, some of the oxygens are being reduced, going from -1 to -2, but we don't need to worry about that for right now, or at all. All right, we'll move some of this out of the way. All right, so our oxidation half is the oxygen. We're just going to take the elements that include the oxidized oxygens, which is the peroxide, and the elemental form for oxygen. We'll balance that later. The reduction half is ClO2 and ClO2 minus. All right, so now we're going to balance the reactions. The first step is balancing anything except for hydrogen and oxygen. In the oxidation half, we don't have anything else. So we're going to go to the next step of balancing oxygens by adding water. We have 2 oxygens on both sides, so that step is also completed. Then we need to balance the hydrogens by adding hydrogen ions. We have 2 hydrogens on the left-hand side, so we will add 2 H+ over here, which then means to balance charges, we add 2 electrons. All right, oxidation half is complete, and double checking that the electrons are in fact on the right-hand side of the oxidation half because oxidation is loss of electrons. They need to be produced in the reaction. For the reduction half, chlorines are already balanced, and then in order to balance oxygens, we need to add water, but oxygens are already balanced. We have 2 on each side here, and we don't have any hydrogens. That one is easy as well. We just have to add 1 electron to balance the charges, which then means this reduction half needs to be multiplied by 2. In fact, let's just do that right here. 2, 2, and 2. That is so that the electrons here in the oxidation half and in the reduction half both get to cancel. All right, we're going to combine everything, and I'm going to do this kind of in the top part of this line because we have to add something different because this is in basic solution. So we're going to write this tiny. If you're following along with me, kind of write it small as well. We have the reactants of hydrogen peroxide, 2 ClO2, and 2 electrons. And then that turns into the products, which is elemental oxygen, plus 2 hydrogens, plus 2 electrons, plus 2 ClO2 minus. All right, so the first things we get to do is cancel our electrons. That's easy. Now what we have to realize is that because this is in a basic solution, we cannot end up with hydrogen ions in the solution because, as we'll learn in our acid-base unit later on, hydrogen ions, when you have more hydrogen ions in the solution, it is an acidic solution. If you have more hydroxide in solution, then that means you have a basic solution. So the very last step for balancing these in basic solutions is adding the amount of hydroxides needed to cancel hydrogen ions. Now you can't just add them to one side, you have to add them to both sides of the reaction. So let's just look at this. I'll do it in a different color here real quick. 1 hydrogen ion plus 1 hydroxide ion turns into water. which is neutral. So because we have 2 hydrogen ions here, we're going to add 2 hydroxides to each side. So we're adding 2 hydroxides. We're just going to add them to any side over here. And these 2 right here will then turn into 2 water molecules. So combining this, let's see if we can follow this. We have this, this, and this on the reactant side. H2O2 plus 2 ClO2, and that's not a negative charge. And, oops, we need to add 2 of them. There should have been 2 hydroxides because we added 2 on both sides of the reaction. And then we have, oops, let's go back to green. The products, we have O2 plus the 2H2O, which is coming from our combined H plus and OH minus, plus 2 ClO2 minus. And then that completes this problem in basic solution. If it was done in acidic solution, you just leave off that hydroxide step. But if it's in basic solution, you'd add the appropriate number of hydroxides to neutralize the hydrogen ions. And technically, in reality, that hydroxide was already there. We just needed to find a way to incorporate that into the problem, and this is the perfect step to do it in. All right, let's do the next one. Nickel oxide. Oxidation states here, -2 for each, which means a total of -4. Therefore, total +4, which means each nickel here is a +4. Zinc is in its elemental form. It is 0. We don't need to worry about the oxygen and the hydrogen individual oxidation states here. We're just going to find the total from hydroxide. Hydroxide has a -1 charge, so the polyatomic ions need to add up to their same charge. So we have a -1 total from individual hydroxides, and then -2 total from the hydroxide, which tells us the nickel is a +2. We can do this because I already know that the oxygen and the hydrogen are not going to be oxidized or reduced. It's going to be the nickel and the zinc. So oxygen and hydrogen individually are not changing. So we just use the full polyatomic ion together. Alrighty, let's go ahead and look at our elements here. Nickel went from over here, +4 to a +2. That is dropping on the number line, which means this one is reduced. Zinc went from neutral or 0 all the way to +2. So that means the zinc was oxidized. So let's put our oxidation half. Zinc, let's add the element or the phase there, and it turns into zinc hydroxide. The reduction half includes the nickel oxide and the nickel hydroxide. All right, now we need to balance our half reactions. The zinc is already balanced. Now we're going to add balance oxygens by adding water. We have 2 oxygens on the right-hand side, so we're going to add 2 water molecules to the left-hand side. We have 4 hydrogens then on the left-hand side, 2 hydrogens on the right-hand side. Add 2 more hydrogens. That is the first time we have a charge in this half reaction. So we add 2 electrons also on the right-hand side, which matches for an oxidation. Half reaction must have electrons on the product side. All right, the reduction half, we need to, nickel is balanced, so we'll leave that. And then we're going to balance the oxygens. We have 2 on each side, in fact, so oxygens are done. We're going to add hydrogen ions, 2 of them, to right here. To balance the hydrogen ions, and then that means we're going to add the 2 electrons here. So we don't need to multiply either of these half reactions by anything because we already have the same number of electrons. So we're going to combine everything. Zinc solid plus 2H2O plus nickel oxide plus 2 hydrogens plus 2 electrons. And then we have on the product side zinc hydroxide plus 2H plus 2 electrons plus nickel hydroxide. We get to cancel not only the 2 electrons, but also the 2 hydrogens on each side, which then makes our next step easy because all the hydrogens are going to already be canceled, and we don't need to do that extra step at the end. Rewrite everything that was not canceled. And as you're doing it, double checking, counting your elements and charges, making sure everything is still balanced. All right, that one is done. Let's go to the next one here. Iron hydroxide. We've got -1 from the hydroxide, total of -2 from the 2 hydroxides, which means this iron is a +2. We have -2 from each oxygen, total of -8. We need to equal -2, which means this chromium is a +6. This iron is a +3. -1 from each hydroxide, total of -4 from the hydroxides. This chromium hydroxide, nasty little business here, is a total of a -1, so that means each chromium is a +3. Alrighty, so our iron went from a +2 to a +3, which means that went up on the number line. Iron was oxidized. Chromium went from a +6 to a +3. It was reduced. All right, oxidation half. We have iron hydroxide turns into iron 3+. The reduction half, so far we have chromium and then our chromium hydroxide that has a negative charge. All right, the iron is already balanced in the oxidation half. Now we need to balance the water, but the oxygens by adding water. So we're going to add 2 waters over here. We have 2 hydrogens on the left side, 4 hydrogens on the right side. So we're going to add 2 more hydrogens over here in the form of hydrogen ions. And then we have a total of 2+ charge on the left side, a total of 3+ charge on the right side. So we add 1 electron. Oxidation half is done. Then we're going to notice that the chromium is already balanced and the oxygens are already balanced. We have 4 oxygens on each side. Now we just need to add 4 hydrogens then. 4 of them. And then we've got a total of, let's look at this. We have 4+ here and a 2- here. So that means we have a total of a +2 on the left-hand side. And then we have a -1 over here. So if we add 3 electrons, that then means we have -1 on each side. All right, that means we need to multiply this oxidation half by 3 so that our electrons can cancel. All right, so we have 3 FeOH2 plus 6 H plus. And then from the reduction half, we have CrO4 2- plus 4 more H pluses, and those will add up or combine later on. And now we have our product side, remembering we are multiplying the oxidation half by 3. So we have 3 Fe3 plus 6 H2O plus 3 electrons plus our chromium hydroxide. Oops, the 4 is on the outside of the parentheses. Okay, so we can cancel our 3 electrons from both sides there. And then if you realize that we've got 6 hydrogens plus 4 hydrogens, that is 10 hydrogen ions. And if this was completed in acidic solution, it's fine to just leave that. You would combine it as 10H plus when you write your net balanced redox reaction. But because this is in basic solution, we need to add 10 hydroxides to the both sides of the reaction. So we're going to add that. 10 hydroxides. I'm adding enough space here so it doesn't look like we have 100 H's. You have 10 hydroxides. So then you can see that all of this cancels and turns into, I'll say, equals 10 water molecules. And nothing on the product side cancels beyond that. So to write out the full net balanced reaction, we have 3 FeOH2. Somewhere in there, just put in your 10 water molecules. Oops, 10. And CrO4 2-. And then the product side, we have 3 Fe3 plus 6. Oh, okay, we're not quite done yet because our 6 water molecules here, they can cancel with 4 or with 6 of the 10 and turns into only 4. So we're going to adjust that right here. We have 4 here, and we don't have any on this side. And then we have, though, our chromium hydroxide. All right, so that should be the end answer for the net balanced redox reaction.